All right, so let's take a quick look at radicals. What is a radical? A radical is a term that has an exponent with a fraction. So it's usually in the form x equals b over a, or the a root of x to the b. The important thing here is that you'll notice that whatever is in the denominator is the type of root that it is, and whatever is in the numerator is the power. So for example, x to the 2 over 3 could be written as the cube root of x squared. The square root of x to the 5 can be written as x to the 5 over 2. In both cases, you'll notice that whatever is in the denominator is the type of root that it is. And if the root has no number on top, there is an imaginary little 2 there, little invisible 2. Alright, so this is what we're going to follow when we're trying to simplify a radical. We're going to break the number inside the radical into its most simplest factors. And we're going to group these factors of the nth root into groups of n. I know that sounds confusing, but let's put it into numbers. For example, if I try to do the cube root of 242, I would put these factors in groups of 3. Then we're going to multiply each group and put that number on the outside, and then we're going to multiply each of the remaining numbers and put that on the inside. So it's easier to show you than to just tell you, so let's do an example. If I try to simplify the square root of 216, I'm going to 1, break into factors, 2, group the factors, and 3, simplify. So how many times can I break this into factors? So one of the simplest factors is 2. 2 into 216 goes 108 times. Now in problems, since you're doing an online course where it says don't use a calculator, it means I don't want you to put square root of 216 just in the calculator. But you can divide 216 by 2 and get 108 in the calculator. That's fine. So we're going to continue breaking this down. And we're going to get 2 again and 54. And then I'm going to break this down further and do 2 again with 27. Now, 27 can no longer be divided by 2, so I have to use another smallest factor, which would be 3. So 27 is 9 times 3, and then 9 is 3 times 3. So that's step 1, is breaking the factors. Now we're only using the numbers on the outside. What I mean by that is whatever has been broken up, we're not going to consider that to be a number. So we're just looking at those outside numbers. We're going to group these factors in groups of 2, since this is a square root. So we have one group of 2 here, and we have another group here. And then the other ones are kind of like loners. So that's a loner, that's a loner. We can't group the 2 and the 3 together. So now we're going to simplify. The pairs we're going to multiply and put on the outside, and the leftovers are going to be multiplied and put on the inside. So our answer to this is 2 times 3 is 6 on the outside, square root, and then 2 times 3 is 6 on the inside. So the one on the outside comes from the 2 2s and the 2 3s, and the one on the inside comes from the single 2 and the single 3. All right. Now, how do I do cube root? I do it the exact same way. Now, the only difference is instead of grouping them in groups of 2, I'm going to group it in groups of 3. So let's erase these little circles because we're going to do different groups now. So we have a group of 3 2s here and a group of 3 3s here. We have nothing left over. So therefore, nothing is going to go inside the cube root when we're done. So 2 times 3 is 6. So the answer to the cube root of 216 is just 6. Now let's do one with numbers and letters. We're still going to follow the same 3 steps: break into factors, group factors, and simplify. So let's start off by breaking off that 32 into factors. So we have 2 times 16, and then 16 is 2 times 8, and then 8 is 2 times 4, and then 4 is 2 times 2. Now this is a square root, so I'm going to have those groups of 2 there. And then we have the loner right there. So number-wise, we're doing the number first. We have 2 times 2 times the 2 that's already outside. So 2 times 2 is 4, times 2 again is 8. So we have an 8 on the outside. Matter of fact, let me leave some space because we're going to have to put some numbers out there. On the inside, we have that leftover 2. So we're going to put 2 on the inside there. Now let's look at these letters. What you're going to do is you're going to divide these exponents by 2 because it's a square root. If it was a cube root, you divide them by 3. Now, whatever the quotient is, the result of dividing, you're going to put that number on the outside, and whatever the remainder is, you're going to put that on the inside. So let's take a look at this. We have x to the 1 in there. 1 divided by 2 doesn't give you a whole number. The remainder is still 1. So we're going to have x to the 1 left on the inside. Y squared, y to the 2. 2 divided by 2 is 1. So we're going to have y to the 1 on the outside. And now we have z cubed. So 3 divided by 2 is 1, and with a remainder of 1. So we're going to have a z on the outside, and we're going to have that remaining z on the inside. Okay? Let's see why this is. I'm going to use that z cubed as what we're going to use to determine why this is so. Z cubed is like saying z times z times z. Now what happens when I try to group these in groups of 2? Well, I get one group of 2 z's, which is why that ends up on the outside, and I have this z left over, which is why that ends up on the inside. The easier way to do this is to say 3 divided by 2 is equal to 1, remainder 1. So the 1 goes on the outside, and the remaining 1 goes on the inside. Alright, now let's simplify 128 to the power of negative 2 over 4. If I was to rewrite this into something that looks familiar, I would be taking the fourth root of 128 to the negative 2, which means whatever factors I get for 128, it's like I double that. Before I do this, I could actually simplify So let's see what we end up with. We have 2 times 2 times 2 is 6. And then for the remainder, we have now again, why is it 1 over? Because it's being negative exponent. Now, we don't want to leave our root 2 at the bottom for some reason. We have this pet peeve about leaving radicals at the bottom. So that could be an answer. But if we multiply the top and the bottom by root 2, what's going to end up happening is we have root 2 times root 2 is a whole number 2, and we end up with root 2 on top. So you end up with root 2 over 6 times 2 is 12. Now, if your options are for decimals, you could have a decimal version of this by just plugging it into the calculator. Now let's look at solving equations with radicals. We're going to locate the variable, work from the outside in, and do the opposite to get rid of something. This is my general 3 steps for solving any equation. So let's locate the variable. The variable is x. So to get that by itself, we're going to work from the outside inward. So the outside thing is 16, and we're going to do the opposite, which is divide. So I'm going to divide both sides by 16. When I divide 30 by 16, I get a fraction, but since we're going to get this answer in decimals, I'm going to go ahead and put 30 over 16 in my calculator, and I get 1.875. Now, to undo the cube, we're going to do cube root. And cube root in your calculator is the same thing as putting in 1.875 to the power 1 over 3. That's the same thing. All right. So if your calculator doesn't have the cube root function, you can put to the 1/3. This gives me 1.23 equals x.